In this video, we're going to go to the bench and we're going to make a 40 meter end-fed antenna. So this is a K6 ARK end-fed kit, and you can use this to make a variety of different lengths of end-feds. The end-fed that I'm going to be making is a 40 meter end-fed, and his kit does come complete. We'll do an inventory of the whole kit here in a little bit, but K6 ARK Adam, he's a portable antenna guru. He makes a lot of QRP kits that you can throw in a backpack and take up into the hills and put up a portable antenna to do summit activations and park activations. That's kind of his thing. But I decided to buy the kit because just to buy one spool of magnet wire that I would use about 6 feet off of and then never use again didn't seem like a good idea. So let's go on over to the bench and see what's in the kit. And here's all the parts of the kit. And of particular importance when you open up the contents of this package and dump it all out, you do not want to lose this. So this is the capacitor. It's actually the first step that we're going to be doing. It's soldering this capacitor on the board. Now, installing this isn't absolute. You don't have to do it. If you planned on running monoband, or if you have a really, really good tuner, like the tuner in a G90, you probably wouldn't need this. But the purpose of this capacitor is to reduce the discrepancy of wire length between the fundamental frequency of the antenna, for instance 20 meters, and the subsequent harmonics, even harmonics, upward from that frequency. So from 20 up to 10, what you would end up seeing is that for 20 meters you'd have to cut this wire a foot and a half shorter than you would expect, and then on 10 meters that would put you high on frequency. So the capacitor is designed to help reduce that effect a little bit. I'm going to install it. If I don't like the result, I can always remove it later. This is a surface mount component. It is a little bit tricky to do these. So let me get this thing out of its wrapper and we will get started on that. You will need a soldering iron for this stage of the kit. In fact, you're going to need a soldering iron for several stages of this kit. And the way that I typically do this surface mount stuff is I will tin the circuit board first, like so. And then I just set the component that I want to solder in there and heat it up until it becomes one with those traces. Typically, this smoothing capacitor has a value of somewhere right around 100 to 150 picofarads. Okay, step one is done. Now we're going to add wire. So I have a 6.5 foot, it's actually a little long, 7 foot counterpoise. I intend to trim it once I'm in the air tuning. And we have our first section of the antenna, which in this case I've cut for 20 meters. So it's about 33 feet, 34 feet, somewhere in that neighborhood. So this wire I salvaged from old Christmas lights. It's 18 gauge stranded, and it's actually pretty good for this. And the way we're going to do this is with the word counterpoise on the board here. We're going to come up through this hole, and then we're going to go down through and I'm just going to solder it. And then for our main wire, which is the actual antenna, it's going to be just the opposite. So with the counterpoise coming out of this side of the board, we want the antenna to come out the opposite side. And if you do it right, what you should have at that point is the wires coming out opposite sides of the board. So counterpoise coming out one side, antenna coming out another side. So the antenna wire is going to come out on the same side of the board as your capacitor. The counterpoise is going to go through the back side, like so. Now we can install the connector. So right off the bat, we're going to take this ground lug and we're going to toss it. So our SO239 is going to go through the same side as the capacitor is on. So from now on, we're going to be calling this the bottom of the circuit board. For this next step, I've tinned these two holes, and you'll need a very short piece of the magnet wire. And you need to scrape the insulation off of this. This is a little bit tricky because the spacer has to sit on top of the SO239. And then in a future step, our toroid that's been wrapped will also have to sit up there. But we need to protect this little short piece of wire from grounding out anywhere. So the spacer has a couple of holes in it, but I think I'm going to go ahead and I'm going to notch it right here. And that's so that that wire can go right down through that notch into the circuit board. Okay, so center pin, center of SO239, and the spacer sits on there very nice, and so does the toroid. Okay, we can set this aside for now, because the next step is to wind our toroid. There are multiple ways to do this. I'm going to do it pretty much the conventional way that these things have always been done, with one exception, and that is I'm not going to do a crossover at the 7th turn. And the reason I'm not going to do a crossover at the 7th turn is because all of the holes on the circuit board end up on the same side of the toroid, so that just makes it easier to solder them to the circuit board. So the first step is to measure out 8 inches of wire, and we're going to fold that back, and then we're just going to twist it. Okay, we're going to start winding this thing. Now, the way this needs to end up is, this is going to be where the end of the twisted pair is. So our 8 inches will be folded back, and I've already cut this off, but that's irrelevant because it's twisted up already. But this is going to be our ground lead, so that has to go through the hole in the board that's labeled ground. And then on our toroid, as we're winding this thing, we're going to come this way, and we're going to have this tail end up just to the left of where we started, and that's going to be the in wire as we're winding in this direction. After we get 2 turns on there, the in wire is going to go through this hole. Then we're going to continue on around. We're going to end up somewhere in here, which is where the out hole is on the circuit board. So it goes something like this. So the first 2 counterclockwise turns that we do, we're winding both primary and secondary, because the primary and the secondary leads are twisted together. So there's 2 turns, and we're going to count it every time it comes through the center of the toroid. So 1, 2. That's 2 turns on the primary, 2 turns on the secondary. Now we can take our tail out of there because we don't need it anymore. Now we're going to continue on with the secondary windings. And you want to pull them tight, but you don't want to scrape them on the edges of the toroid. As far as spacing goes, we have 2 turns on the primary, and we have 14 turns on the secondary, and half of 14 is 7, so we're going to try and gauge this so we get halfway around this toroid on the 7th turn. So now we have 1, 2, 3, 4, 5, 6. And there's 7, that's about halfway. Okay, where are we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 14. And there's our leads. So if you did this correctly, you have the tail from our two-turn winding going in, then the twisted pair going in ground, and then what you just finished up, the last turn that you just made, will go to out. I'm going to trim. I can trim that right there. Right there.
Going to bed. No.
And once you get the wires scraped, you just add a little bit of solder. And that's what you should end up with. All right, I'm going to run out in the garage and use a heat gun to shrink this down. Okay, we're getting pretty close to the end. So my intended usage for this is as a backup horizontal antenna. So I'm going to install this in a semi-permanent permanent fashion. And for that, we're going to need a little bit more waterproofing than this has, of course. So what I'm going to do is I'm going to employ an 1.5-inch coupler, and I've drilled 2 holes in it. And then I've cut a very thin sliver of 1.5-inch plumbing pipe, and I got something called an 1.5-inch knockout. And what we can do is we can slide this over the knockout. That becomes a shim, so that we can put this on, and that caps it and keeps the water out. And then what I'm going to do is I'm going to zip tie it to this. This is just what some paracord came on from one of the local hardware stores. I can't remember which one at this time, but one of the local hardware stores had about 50 feet of paracord, and it was wrapped on this. So this will make a nice thing to wrap the wire on. And then I can also, once I get it together, I can just hook it onto my tower to make a semi-permanent installation. But first, let's go ahead and put the wires through. So I've drilled these holes, one slightly above the center line, one slightly below the center line. I'm going to come up in the one slightly above the center line. I'm going to put it through there. This will be our counterpoise wire. And this is a snug fit, but it will go in there. The only reason it's a snug fit is because there's a ridge in there. But I like the fact that it fits snug, so I'm going to leave it alone. Now once I get that in there, I'm going to take the main antenna wire and put it through the other hole. Just like that. And now as it's up this way, there's no way the water, well, it'd be very difficult for water to get in there unless it was really blowing. And with this on top, I'll put some glue on that and seal that before I put it together. And then we'll just zip tie it right to that. And then when it's all up in the air and the antenna wires are pulling out and the coax is pulling down, it'll be just fine. So I mentioned that I wanted the ability to turn this into a shorter antenna. So instead of 40-meter length, which is about 60-ish feet, 66 feet or so, 65 feet, if I can quickly disconnect some wire and turn it into a 20-meter length portable antenna, that might come in handy for setting up portable in places where a 40-meter length of wire wouldn't fit. So the way that I'm going to accomplish that, I'm just going to use this little tiny dollar store carabiner, and I'm just going to wrap a bare wire loop around this several times, then have another section of wire that I can clip to lengthen it to 40-meter length. And you may be asking the question, is this a good conductor? And the answer to that is yes, it is. So I get 0.5 ohm with the lead shorted out. I get about 0.6, 0.7 of an ohm. Checking the resistance of this carabiner, so it'll work just fine. So I'll just wrap this. This will be a permanent installation, so when I'm using it as a 20 meter length antenna, I'll attach paracord to this end of it to string it up wherever I'm going to string it. And then if I want to add a length of wire so I can use it on 40 meters, I'll attach more bare wire to this. And this will be an electrical connection between the two halves of the antenna. Here's our completed end-fed half-wave. And as I mentioned, I wanted this to be a linked antenna. So for portable use, I want to be able to set it up as a 20 meter antenna with a shorter wire, and then have the ability to link another piece of wire on there to make it a true 40 meter antenna. So I'm going to go over, so I'm going to set it up as a typical portable outdoor antenna, something you might deploy in the field. And that's going to be pretty low to the ground, and the ends of the wire are going to be pretty low to the ground as well. So we'll set it up that way, and then we'll hook the coax up and we'll tune it for that first and nail 20 meters. And then after that, we'll link another piece of wire to it, put it up in the air farther, and tune it for 40. So hopefully this goes like I plan it to. So the first step is to throw a wire up in a tree, or throw a rope over a limb in a tree and get this thing off the ground. So that would be a typical installation. We get counterpoise of 7 feet, and then we have our antenna wire running out there, and it's about 34 feet. So now we'll go inside and we'll do a Nano VNA sweep and see where we're at. So I took a foot off the counterpoise. I just folded back a foot on the counterpoise, but we're still a little bit low on frequency. So now I'm going to go out and I'm going to shorten the actual antenna wire. We're a full megahertz low on frequency, not quite a full, about 800 kilohertz low on frequency. So I'm going to shorten it about 8 inches. So this is with 8 inches of the main antenna wire folded back on itself to electrically shorten it. And you can see we came up to 13920, and you can already see the problem with multiple band antennas. We're resonant 13920, which is just below the 20 meter band. And then the other band that we would want to pick up and use on an end-fed would be 10 meters. And if you look at 10 meters, it's resonant at 29,520. And if we look at the 3-to-1, we should be okay. So there's the middle of the band, 28,560. So my radio will tune to that, but you can see it's not ideal. Now, the problem is if I shorten it a little bit more so that I get a better SWR on 20, then that's going to push 10 even higher. So this is the sort of thing that you run into when you're using an off-center fed or a end-fed antenna. So let's see, 14,880, 42 ohms, and then 29,520, 33 ohms and 1.6 to 1. So I think from the looks of things, I'm still low on impedance. It needs to be higher than 33 and 42 ohms. So I'm going to go out and I'm going to shorten the counterpoise. And that's with the counterpoise shortened an additional 6 inches. So we're 1.3 to 1 on 20 and 1.7 to 1. I think it actually went the wrong way, but I think I will leave it there. But what we really want to know is, can I tune to the high end? Will it tune to the high end of 20? So the answer is yes. Now, will it tune to the low end of 10? And the answer is also yes. So that achieves what I wanted to achieve. I'm going to leave it right there. Okay, so now that we know we've got an operating 20 meter antenna, I went ahead and I added a 34-foot piece of wire with this little tiny carabiner. This is actually a smaller carabiner than I had earlier. I found some smaller ones. And these were anodized, so I just scraped the anodized coating off of it so it will make a good connection. These are aluminum, so it'll work just fine. Aluminum's right up there with copper when it comes to conducting electricity. So the next step is to go hang this thing up in the air and tune it. Okay, I've got this antenna up in the air, and I've had to make two adjustments. The first adjustment was the counterpoise. As you probably know, when you're setting up the counterpoise, it should be about 5% of the total length of the band that you're working on. For instance, this 40-meter antenna, 5% works out to about 6.5 feet. So I had to shorten that counterpoise for 20 meters down to about 3 feet. And to get it to work on 40, I had to lengthen it back out to the 6.5 feet spec that I started with. And now that we've done that, we've got really good numbers out of it. It's 1.1 SWR, and we're slightly low on frequency at 6.960, which is where you want to be, and I'll explain that in a minute. And we're at about 45 ohms for 40 meters. And now if we go up to 20, at 14,400, we're 1.3 at 14,400, and that's about 43 ohms. And then we've got some 15-meter action going on. So at 21,840, we're 1.4 to 1, which is 55 ohms. Now you notice the first two readings were below 50 ohms, and this one is slightly above 50 ohms, which tells us that our counterpoise length is just about spot on. And in our 10-meter band at 29,280, we are 1.5 to 1 and 69 ohms. So here's those numbers. Now the thing is that this is how you should tune an in-fed and an off-center fed antenna. And the reason for that is that you'll notice we're slightly low on 40 meters, we're slightly high on frequency on 20 meters, we're significantly high, well, let's see, 21.5, where does it end up on 15? It's like at the top edge of the 15-meter band. And then on the 10-meter band, we're significantly high at 29,280. So the next thing to do is I'm going to hook this to the radio and see if I can tune to the top edge of 40, the bottom edge of 20, and then I think 15 is okay. And I'm going to try and tune to the calling frequency on 10. See if the radio is capable of tuning to those frequencies. If it is, we're done. So this would be, end-feds and off-center feds are almost impossible to use on a radio that does not have a tuner, or if you don't have an external tuner. So if you're running something like a FT891, you probably don't want to use an end-fed. It's not going to work for you. It'll be a monoband antenna because you'll be able to tune for 40, but then 20 will be way high, and the other two bands will be even higher. If you tune for 20, then 40 will be way low, and 15 would probably be right on, right in the middle of the band. And 10 might be closer to usable frequencies, but it's still not going to be ideal. It's still going to be high. So let me hook this up to the radio, and we'll see if we can tune to where it's at. And if we can, then I'm going to call it done. So you can also kind of get an idea where your antenna is tuned by looking at your waterfall, because you'll see up here in the middle of the band, the signal strength is a little less, and as you go down in frequency, remember this antenna is tuned for 6.9 megahertz. You can see how this is coming up. Now we're in the middle of a solar flare, and that's where all this noise is coming from. You can kind of see where this antenna is resonant just by spinning around. So what I want to do now is I want to go to the top edge of the band, and at the top edge of the band, I just want to see if it'll tune up there. And the answer is no. So now let me go down to the middle of the band. And I was able to tune to 7,250. So we got partial coverage on 40. Now let's check 20. So what we want to do here is see if we can tune to the bottom edge of the band. And we're able to get 20 at the bottom edge of the band. So we're good there. Now let's check 10. And for 10, I'm just going to go up to the calling frequency and see if we can get the calling frequency to tune in. I doubt it. It's pretty high up there. And once again, it looks like we're okay. So it's usable on 10, it's usable on 20, it's partially usable on 40, which means I think the next time I take it down, I might shorten it another 6 inches or a foot. 6 inches. We'll start there and see how that goes. So the next thing we probably need to do is I want to see if we can see anybody keyed up. So here we are at 7260, and I'm not even going to let you listen to that audio because these guys are idiots that have their licenses revoked. But anyway, all I'm going to do is look at the S meter, and I'm going to switch back and forth between my fan and the end fed. And you can see that the fan is a little bit more sensitive. It's like an S unit difference. Okay, now let's do the same thing on 20. This is just some FT8. We'll see how that works. That's the fan. That's the end fed. That's the fan. That's the end fed. So, kind of what I expected. Center fed dipole is always going to be a little bit better than an end fed because of losses through the transformer and other losses. You may find some areas where the end fed will do better, especially on multiples of the frequency that you're looking at. Let's see. Let's check this one. Yeah, see on that one, it looks like the end fed might be a little better. So if you have 40 meters of wire in the air and you're on 20 meters, the end fed becomes a multiple wavelength antenna, and you get some lobes shooting out that will have some gain attributed to them. So it's possible that the end fed might be better than the fan on some frequencies. That's the fan, that's the end fed, fan, end fed. So it looks like the fan's a little better there. Now you can see we're coming up into the area of this antenna where it's tuned. Okay, that's the fan. That's the end fed. Fan. End fed. Fan. End fed. The end fed seems a little bit noisier there. So anyway, they're both dipoles. It's just they have a slightly different operation between the two of them, but it's a good viable antenna. It's a really good portable antenna, and it's an option for me. Now I have two 40 meter and 20 meter antennas up in the air, so I can switch back and forth as I see fit. So I'm going to leave this up for a little bit and just play with it, listen to some signals, get into some QSOs, and switch back and forth and see if it's worthwhile to leave it up in the air and go from there. And as always, thanks for watching.